Hello, Topcoder. My name is Andy Lamora, and I'm a partner at Topcoder, serving our public sector and higher ed customers. Today, we bring you Red Hat. Red Hat was one of our premier sponsors at the Topcoder Open 2016 at the Booz Allen Hamilton DC Innovation Center in Washington, DC. If you were there, you may have had a chance to talk to Kathy or Sampa, who were either in the arena or at the party. Both of them from Red Hat. And the EPA Hackathon also ran on Red Hat's OpenShift product. You may have had a chance to check it out there. So OpenShift is pretty cool. We found it to be really easy for supporting our challenge and are interested in what it can do to let scattered teams collaborate on projects at the same time, and especially how it uses containers to push things easily through CI, CD, and into production. So we asked the Red Hat team if they'd be willing to showcase OpenShift again for Topcoder, but also for our community. Lucky for us, they agreed to do it. We're delighted to have them here today. So I'm here in quotes with Steve Pusti of OpenShift team, and he's going to take it from here. Hope you enjoy what you're about to see, and please feel free to fire in questions. Nick Steele and I will be fielding them. Just enter them right into the chat on the Hangout. All right, Steve, over to you.
Thanks for inviting me in. I'm excited to give this talk today. We are both here, although my here is sunny and warmer than yours. Mine is 63 degrees, as opposed to yours somewhere in the 30s. I'm the lead developer evangelist for OpenShift Online, and I'm going to take you through a short slide deck, and then we're going to do most of the time doing demos. And like they said, I really prefer questions during the talk, because if you're missing something or you're stuck on a concept, or if I can answer it right away, I'd prefer that rather than waiting until the end when you may have forgotten or it's not quite as appropriate. So let's go ahead and start the slide deck. So go ahead and present. So today I'm going to talk about container orchestration. Ooh, I got to share my screen. That would help too. There we go. So today I'm going to talk about container orchestration with Kubernetes and OpenShift, and that's me. And there's all the coordinates you can find me, including my email. Just put that's a 0 rather than an O, because I'm leet like that. And that link on the bottom is actually where you can come in and look at the slides right now if you want, or if you're watching this later, you can see the slides will be up there. That's a bit.ly link that'll get you to these slides, okay? So the goals for today, very simple: background on containers and at scale, like how you run, what's required to run them at scale, and then a demo. So let's start with containers. I'm sure most of you have actually encountered containers already. The most popular container format out there right now is Docker, but containers have actually been around for quite some time. If any of you worked on Solaris zones were containers, BSD change root jails are containers, LXC is containers. The older version of OpenShift v2 used our own custom containers as well. But then I think the explosion that we're seeing has come just recently. So the difference between a hypervisor system and a container system is, on the left, you'll see you have the infrastructure, the host operating system, and then a hypervisor. And then for each app that you're spinning up an entire OS with its bins and libraries, and then the app itself. So to boot that app or to do work on that app, you actually have to spin up an entire OS, grab all the memory that OS needs, and then it also needs to have all the processes running for the entire OS, which may or may not be needed by the app. In a container world, what you usually have now, and which probably most of you are familiar with, is the infrastructure, the operating system, and then a container engine like Docker engine. And then inside of that, you'll have all of the containers running on top of that. And what each container brings up is only the binaries and libs that it needs to run. They're actually sharing the kernel from the host operating system, right? So anything your app needs, and only what your app needs, is what you can put in your container. And this has several advantages. One, it's lightweight and it's fast to start. Two, you don't have dependency hell. For any of you who've actually worked with on a Linux system or even on a Windows system, when there's two different versions of a dependency that are needed by two different applications, you're stuck. Because it'll say, well, no, I can't replace that version of GCC because this other thing needs this version of GCC. Well, in the container world, both containers are bringing what they need, and it could be their own version of GCC, and you can have them both on the same machine. There's no conflict in that situation. And then the other thing that's nice about this is you can more efficiently use your entire machine. Right? You can do more load sharing and burn your server white hot, right? once you've bought, whether it's a virtual server or a real server, once you've bought that server, you want that to run as hot as possible to maximize your investment. And containers can help you with that. Are there any questions out there on containers? I'm pretty sure most of the audience has heard of them and understands them. And I'm pretty sure most people, or a majority, have actually probably tried something like Docker, or maybe Rocket, that's another container specification, or maybe even the OCI containers. And I think a lot of developers, they try it, and they're expecting it to be this awesome thing. And for me, when I tried it, after having used a platform as a service before, I was like, oh, well, that's kind of interesting. It's kind of like a lightweight VM, but I don't understand how I'm supposed to orchestrate a whole bunch of these together, or how I'm supposed to scale it up or scale it down, or connect it to a database really easily, or to expose it out to the outside world. And so to get that kind of functionality, you need to move past containers. And so, containers have done a lot of really interesting things. In evolutionary terms, we have this thing where there's the Cambrian explosion. There's very few species. And then there was suddenly, during the Cambrian explosion, this mass proliferation of species. And I think right now, what we're in is a time of container explosion. So while you may have played with Docker, and you may have played with a little bit of technology on top of it, I think you need to stay in this space because there's a lot coming over time. I think containers have enabled a large variation in this space. We're seeing everything from Mesos to Kubernetes to Docker to Rocket. There's all sorts of things happening in the container space, which are really interesting, and you should keep your eyes on it. And so one of the things that we as Red Hat have focused on to handle some of those bigger questions is moving past just containers, and we need stuff for orchestration and scheduling and isolation. And things that give that, the project that we've picked, the open source project we've picked, is Kubernetes. Kubernetes originally was started out of Google. It is an open source project under the Apache license. And just like the Linux kernel is part of Red Hat's core value proposition, you can think of Kubernetes as Red Hat's cloud kernel, right? So in the same way that Red Hat doesn't own the Linux kernel, we don't own Kubernetes. But we are the #2 contributor to the Linux kernel, and we're the #2 contributor to Kubernetes, right? We believe in putting everything upstream. So a bunch of the stuff that you'll see coming in Kubernetes is actually started in OpenShift first, which is what we're going to come to later. It's the piece we built on top of Kubernetes. But we push a lot of our changes back into upstream so everybody can benefit from them. One of the other things is, in the same way that when you buy Red Hat Enterprise Linux, you don't just get a Linux kernel and nothing else. You put a whole distribution around it, so it makes it actually useful for day-to-day use for most people. We're doing the same thing with Kubernetes as well. So Kubernetes has become the core, and around that, we're building all sorts of interesting utilities and functions, OpenShift being one of them. There's others that we have as well, but today I'm just going to talk about OpenShift. All right, and so what Kubernetes does is it allows for that orchestration and scheduling. It came out of Borg and Omega at Google. These were internal container projects. Basically, everything Google does, it runs inside of containers. And Borg and Omega are their early versions. Google launches about 7,000 containers. Well, this is probably 2 years old, so it's probably higher than that now. But Google launches about 7,000 containers a second. If you've ever used Gmail, which I'm assuming everybody here has, when that web interface comes up, you are getting your own container spun up inside of Google. So you have used containers inside of Google as well. And they wanted to iterate the next version as an open source project. And so we've been, even before it was released, we've been active upstream contributors to it. And that's where Kubernetes comes from. But it's still not enough for developers, right? You still need a developer experience. How do you manage your applications and a sysadmin experience? The core basis when Kubernetes first started was to help Google iterate their next version of running containers inside of Google and on Google Cloud Engine. Right, or Google Container Engine. And we've actually said, well, that's great, but we actually have some really interesting use cases, we as Red Hat, for people to run it on-premise, or maybe they want to run it on Amazon, or they want to run it on Azure. And so we've been working upstream in a project called OpenShift to make that happen. And there's 3 different versions of OpenShift or at least 3 different versions of OpenShift that I want to talk to you about. OpenShift Origin is the upstream. So that is where we do all our work. Just like every other Red Hat product, there is an open sourced version of it. That's where all our engineers work. All our fixes and changes go in there. And then every quarter or so right now, we release OpenShift Container Platform. So this is where you can take OpenShift and bring it internally. So this is really helpful in the EPA case, or maybe in a case that you're thinking of hacking on, the company or the company or organization you're hacking for, they can put OpenShift internally, be it either in someone's public cloud, but it still belongs to them, right? It's not a hosted version. They've actually installed the bits, or they put it on their own servers. And you can hack on some other server that you've worked on, or maybe we're hosting, OpenShift is hosting the servers, and you can move your project seamlessly between them. Which also ties into our other product is we have OpenShift hosted. We have dedicated and both publicly available. Dedicated is where you come and you say, I want an OpenShift cluster, and we host the cluster for you, and you just use it. And then you're not sharing resources with any other company or organization. And then we have a public multi-tenant cloud, where it's great for beginning developers or developers who aren't big enough to really pay for their own cluster, but they want the ease of use of using containers. They want the power of Kubernetes, but they just want to use their code. And I'll show you part of the parts that we've built on top to make it easy for you to use your code. But then it also makes it easy to transfer to any other organization that has OpenShift on there. Even if you don't use OpenShift, the containers that we use in OpenShift are straight. Right now, they're just straight Docker containers. When Rocket is fully supported on Kubernetes, you can also bring straight Rocket containers. The idea is there's nothing secret about any of the containers. You can take them back out of OpenShift or Kubernetes and run them anywhere else if you want to. So are there any questions? I'm just about done with the high-level talk. Are there any questions about that? Is my speed a good speed? Any kind of feedback you want to give, that'd be great.
Hey there, Steve. This is Andy. Sorry, it took me a minute to get off of the mute.
Okay.
I've got a couple quick questions for you, and maybe you're going to hit them later. So feel free if you were.
Okay.
But one that came to mind is I know you guys have CI/CD set up on this thing.
Yes.
And I think I recall that it's Jenkins by default. But
Yes.
is that true? And is there an option to replace it, and how hard is that?
So yeah, we can provide Jenkins out of the box. It's one of the things that you can get out of the box if you want. By default, we do use Jenkins right now. It is pluggable, so we don't call it necessarily a Jenkins pipeline. We call it a build pipeline for just the same reason that we have, if you think of who Red Hat's customers are, and you think about what they bring internally on an enterprise set, they're not all going to run Jenkins. And we're not the kind of company that comes into a place and says, oh, well, we know that you're using Garrett, but you know what? Tough. You have to use Jenkins now. That's just not the kind of company we are, and we know our customers don't expect that from us. So yes, that build pipeline is pluggable. It's in various stages of development, how pluggable it is. I would say at this point in time, it's a little bit harder than you might expect it to be to use another CI/CD server, but that's constantly being improved. And if you want to work in the upstream, you can work in the upstream and see what we've got going there as well. Does that answer your question?
So Red Hat is famous for working with open source code, and you've mentioned already, Kubernetes under Apache 2 and so on. If somebody wanted to contribute to the OpenShift package, what would they, is that possible, A, and then B, what would they have to do?
So it's completely possible. It depends on what level of the project they want to contribute. A lot of our engineers actually work directly in the Kubernetes project because that's where most of our work for the base infrastructure actually happens. And so to do that, you just follow the guidelines for Kubernetes. To work with us, you just go to openshift.org and you'll see where the source code repo is. And then, you can always go in and put in a pull request if you want. It's all written in Go. You can always go put in a pull request if you want. That's probably not going to be the most productive way to do it. The most productive way is start hanging out in the IRC channel, maybe open an issue, talking about the pull request you want to do, and get back and forth with our contributors, and then see how that can merge in together. We have customers doing it, and we have individual contributors. We have all sorts contributing to it. We also have, if you go to openshift.org, you'll also see we have open Trello boards. So Trello is a hosted service that kind of allows you to do like Agile or Kanban boards. And we put all of our cards that we're working on for each sprint. We are on a three-week sprint cycle. And so all the cards are up there. You can start talking on a card there, or you can see one on the backlog and say, hey, that's really an interesting card. What would it take for me to move this into the sprint and let me work on it? We have that. We have GitHub issues and we have Bugzilla issues. Start with GitHub issues, though. Those are easier, though.
Right on. So that gives me the perfect segue to ask the personal question.
Yes.
Do you Basecamp or do you Slack?
We're Red Hat, so of course we use IRC. There, and then I use Slack. My team uses Slack. There is movement also within Red Hat to put up our own hosted Rocket Chat as well, which is the open source Slack. It's called Rocket Chat. But I use Slack. I'm in several different channels. The OpenShift team does not use Slack. There are basically the engineers, they're hardcore Linux people, and they're all on IRC. So they're on Freenode in pound OpenShift or pound OpenShift develop.
Got it. So one of the things that impressed me, and keeping in mind that I'm on the sales side, maybe it's not that hard to impress me, but nevertheless, it did, was when we were working on the EPA challenge, we sent you guys what we call a starter pack. So it's literally a bootstrap framework that our contestants can use to get started on projects. We have a starter pack for mobile. We've got a starter pack for web, and so on. You get the idea.
Yep.
We sent you guys our web API starter pack, which did a lot of interesting things like stubbed out options for Node, for Heroku, et cetera, et cetera.
Right.
You guys got literally every single one of the stubs on that thing up and running overnight. So when you guys provisioned an instance for us, we came back. It was up and running.
Yeah.
Is that?
So
I don't know.
That's actually not that hard. I'm not familiar with what you're talking about, but I'm probably familiar with the technology that we used on our end, since I wasn't exactly involved in that, bringing up that instance. We have template technology, and I'll get to that in a bit. I'll show you how easy it can be to make a template. And basically what it is writing some either JSON or YAML that specifies all the pieces you want in your app. And then when a new person starts up their app, you can just put that in the dashboard and they can click it and they'll be good to go. It'll start all that right up for them right away. And I'll show that later in the demo.
Right on. Thank you very much. So with that, let me get out of your hair and let you go to the demo.
Okay. So I want to, before we go into this, I'm going to go into some basic terminology, and we'll come back to this again if we need to understand it. I'm not expecting anybody to memorize this. Part of why this is also in here is so if people come back later with the slide deck, they can look at it and understand it. What you're looking at now is an OpenShift cluster and the topology of it. So there's masters, and that's what all of my command line and web console is going to talk to. And both the command line and the web console talk through the REST API. So there's no sneaky backdoors for one or the other. You could actually write your own code against the REST API if you wanted to automate stuff that you didn't see in the developer CLI or the web console. So you can do your own automation there as well. And then when we do work, it's actually going to go, all the containers are actually going to run on the nodes. So the master is going to actually take care of what goes where on the node. And one of the things I really want to point out, and this is what's different about the Kubernetes and OpenShift architecture, is that yellow data store in the master. What that actually is etcd. And so in the old version of OpenShift, what we would do, and in most other platforms as a service like this, you would execute a command, and then the master would go out and start looking for a node and tell the node to go do something, and the master would wait, and then when it was done, report back to the user. The new model for Kubernetes and OpenShift is a declarative model. Basically what you do is you specify the truth, and that can either be in a JSON file or you can use the API to make the truth. Like this app has a Mongo database, it has a Node.js, it has an ActiveMQ message queue, and it exposes it. For the Node.js, it uses this Git URL to build the Node app. You can specify all that in the file or do it piece by piece in the API. But what happens is you then feed that into the data store. The data store then represents the truth of the world. And what's happening is the cluster is constantly checking in with that data store saying, hey, does the world match the truth? And if the world doesn't match the truth, it's up to the cluster to make the world match the truth. So that way, suppose a whole node goes down, the cluster will check and you lose, let's say we lose both that Couchbase and that JavaScript pod in the top, in the middle. If that went down, the cluster would say, oh, I'm supposed to have 2 Couchbase pods and I'm supposed to have 2 JavaScript Node.js pods. And neither, I've only got 1 running because in the first column, you can see there's 1 JavaScript and 1 Couchbase. I'm supposed to have 2, I've only got 1. it'll then start to spin up those containers on other nodes that still exist to make the world match the truth. And so you get, based on that declarative model, you actually get to get a lot of features out of the box, some of which I'll show today and some of which you'll learn and explore. Things like that auto self-healing like that, but also things like health checks and a whole bunch of other stuff. We also include a Docker registry. This is not typically in a Kubernetes cluster, included with a Kubernetes cluster. We think most people are going to want some sort of container registry to work with, and because we include it, we can do some fun hooks with it. We've got metrics and logging. We actually have a routing layer as well. We provide a service layer, which is the software-defined network. Kubernetes needs one, and we actually provide one out of the box, which makes it easier for people. And then we have persistent storage. So one of the things for people who've played with Docker, you probably noticed that two containers can't share the exact same container file space. Yes, they can mount external stuff, but they can't share the same one. Kubernetes gets around that with persistent storage. It also gets around the idea that you have to have somewhere, that you have to have some specific file system. That persistent storage is actually pluggable. So that could be NFS, that could be Gluster, it could be Ceph, it could be some large EMC data switch, it could be iSCSI. Those are all pluggable into the cluster as a whole and then exposed to developers as they need it. So I just wanted to show a little bit of that just so people get the architecture. We're gonna go, I'll come back to these. These are basically going over the pieces of the API that we're gonna interact with today. Everything in yellow is OpenShift, built on top of Kubernetes, and the blue is actually something that comes from native Kubernetes. The value add that OpenShift does is we provide a better developer experience and some more ease of use for administrators in terms of running this experience. And I'll come back to that as we go through this. The first one I'm gonna actually do, it's time for a demo, right? Enough talk, time for demo. So the first one I'm gonna do, I'm gonna show you the web console. Here I am in the web console. You can see I'm logged in as user. I don't have any projects, right? And so what a project is, if we go back to this, a project is a materialized Kubernetes namespace. And what a project or a namespace is a place where you just put all the pieces you're working on. And what I mean by materialized is in the first versions of Kubernetes, if you logged into a Kubernetes cluster, you could see all the namespaces. So as long as you could get in, you could see everybody's project. And for us, we knew we needed it to be multi-tenant. So we added users and groups and authentication into that. And the authentication is pluggable. It could be our own based one, or you could use Active Directory, an LDAP, normal LDAP server. There's all sorts of pluggable mechanisms there. And then what we do is we say, yes, you can see this part of this namespace, or you can't see this namespace at all based on your users and groups. So let's go ahead and make a new namespace or a new project, and I'm gonna call it basic. And the first thing that I'm not gonna add to the project from here. We'll come back to this one later. I'll go to basic. And what I'm gonna do is I'm going to add to the project a Docker image. So what I'm trying to show you here is how easy it is just to run a standard Docker image inside of OpenShift. So we're going to pull down an image straight from Docker Hub, and it's going to be the Nginx 1.6 on CentOS 7. So that's that looks just like a Docker image specification. It's warning us that this runs as root, which will not be permitted by your cluster administrator. It is in this case, so we're going to keep going. We can give it a name, we can do some other stuff with it, but we're going to create that, and we'll watch it come up. But what's happening is it's deploying the Docker image into a pod. It's up now. It's up and running. And I'll show you something else about it that's actually kind of fun as well. We can go to application services, and there's the service for it. I'm just going to make a route, which is a URL. I'm going to keep all these the same. So we're going to call the route this name. The path is going to be the straight path. It's going to talk to this service on port 80. Don't worry if you don't quite understand everything that's happened. I'm going to go back and explain it in a second. So there's our route, and it gets a 403 forbidden. It's serving up from Nginx, but there's no content there, so it actually doesn't serve up anything. So let me actually explain to you what we just did. Behind the scenes, when we said run this Docker image, what it does is it makes a pod. And the base unit in Kubernetes is a pod. It's not the container itself. We put all containers into pods because pods get around some issues that containers by themselves have. So for one thing that you can do with containers running in a pod, you can have multiple containers running inside of one pod, right? And so those containers can actually talk over localhost 127.0.0.1, and they can see the same file system. Now, your first reaction might be like, oh, well, I'm going to put my database and my web server in the same pod. That's actually an anti-pattern. The only things you usually put in pods are things which can live and die together and which require seeing the same file system or require talking over a localhost. So an example might be like a database and a database monitor. That you would put in the same pod. In general, you would want to keep your web server and your database in separate pods so they can scale independently, right? And you can actually specify different configurations on them and everything. So in general, any new thing you're bringing up will probably go in its own pod. So we brought up a pod with Nginx in it. And then what I showed you was the service. And what a service is in general, containers come up and down, pods come up and down inside of Kubernetes. They may get moved to a different host. So IP addresses for pods can change. The number of pods can change as I scale up or scale down. And you don't want to have to hard code IPs or keep track of how many of different pods are coming up or down. So what happens is services are guaranteed to retain an IP address for the lifetime of the cluster unless they're deleted. And so what happens is your web server would talk to your database pods through the service. So services are a proxy and a load balancer, right? So services act as a way to route between different sets of pods. In this case, we wanted to expose it to the outside world, so we made a route. And all that a route is, it's a rule in the routing layer that says whatever comes in with the host header X, like X accept host header 4 or the request host header, send it onto this service, which then sends it onto the pod. So the router is actually looking for requests and then sends them onto the direct service. Are there any questions about what I just talked about there? Okay. I'm assuming there's none, or we can interrupt back. So you're saying, well, that's not very fun to have this 403 forbidden, and I agree with you. So what I'm going to actually do now, the reason why is because if we go back and we look at the pod for Nginx, it did a mount, right? So the HTML content that it's looking for, it's doing a mount. So it's mounting actually local file space. If you see it here, it's an empty directory, which is on the node machine, and it's an empty directory. So there's no content in it. So that's why you're getting the 403. This was caused by actually having a volume statement in your Docker file, for those who understand what that means. So what we're going to do now is actually put some content there, right? So we can see something. So one of the fun things that OpenShift also allows you to do is we can actually terminal right into the running pod or the running container. So here I am in the running container, right? I can do who am I? Remember it said it wants to run as root, so you can see I'm root. And I'm just going to do a simple little copy and paste, if copy and paste will work for me today. So I'm just going to echo hello world into an index.html file in that place that it had mounted. Let's paste. There we go. So what I've done now is I've created a file on that disk space, right? And now if I go back to the route, up here again, there's that route. You can see there's my content. Maybe you can't see, but now you can see it says hello world. So I've actually wrote the file to that disk space, and now it's actually serving up. So that's how easy it is to work with Docker containers on OpenShift and get them running. Oh, there's also, I can look at the logs. So there's the log files that are happening there. There's events, right? And one of the other things that's super fun to do is go to the deployments. We'll go to this one. No, sorry, I'm going to go to the overview. I could do it there, but it's more fun to watch here in the overview. I'm going to scale up to 3 pods. So now I've actually got 3 different pods, 3 different containers, all running Nginx. And because they're running behind a service, when requests come in, they can all get round-robin load balance between each of those 3 running pods. You can actually do auto-scaling here if you wanted to, where it would go, currently it's only based on CPU utilization. In future releases, it'll also be based on custom metrics if you want to make them. But when CPU goes above a certain threshold, it automatically spins up another pod, plugs it into the service, and then it starts serving content. When it goes below a threshold for a certain amount of time, it then actually shuts the pod down and gets rid of it. So let me scale this back down to 1. And that's the end of my demo for just showing a normal Docker container running in OpenShift. Were there any questions that came in?
Nice. Thanks a lot, Steve. That's pretty cool. One really a high level question, I guess, is just access to OpenShift. And I know you mentioned in your opening that there's an on-prem option, but what if someone's a startup and they want, they want someone to work on their transactional e-commerce piece? I'm showing my age there when I say that, but their com spot, they have someone else, they want someone else working on, or a different team working on their customer support, et cetera, et cetera. What options do they have?
So if they don't want to run it themselves, OpenShift themselves, the two options they have, the only supported option that they have right now is to buy a dedicated cluster, which means, or to get a dedicated cluster, which means you contact our online services team and they spin up a dedicated cluster for you. And then someone in your company becomes a cluster admin, and then they can allocate projects to people with different amount of resources. And then the team members or the cluster admin can assign roles within each project. So let's say the e-commerce people, the transactional e-commerce people need to be able to see the payment system, but those are two different projects. They don't need to change code, but they need to be able to see what's up and running. They can actually be given view access to the payment system, or vice versa, right? And so they're able to manage that cluster and give permissions out. That's why we have users and groups there. Coming sometime early next year, we'll actually have the online tier, which is you can pay on a consumption basis, like how many pods you need to run, how much disk space you need to attach. And that'll be, you just sign up with your GitHub credentials or your email, and then you can start purchasing and start using that way on a much smaller basis. But that'll be coming early next year.
Oh, right on. Very cool.
The other thing that they could always do, and we have people doing this, is you could take the origin bits and install them yourself and run them. We actually encourage people to do that. I mean, we like people paying for the bits, but not everybody needs to pay for the bits to start with, or even ever. Some of our we have a company called GetUp Cloud based out of Brazil that uses OpenShift Origin to give their own hosted provider service, and they run it on Microsoft Azure, right? And they're using all the open source bits from upstream.
Oh, wow.
If you wanted to think about it, the upstream bits are kind of like Red Hat Fedora, which is cutting edge, bleeding edge. You can't get support contracts for it or anything like that, but if you're comfortable doing it, you can use it. And then OpenShift Container Platform, the pieces you install yourself, is like Red Hat Enterprise Linux, if that makes sense.
Gotcha. Definitely looking forward to that, especially with the trend to everything to be offered as a metered service.
Exactly. That's coming.
Just a couple, just quick question out of curiosity.
Yeah.
What are you guys using for infrastructure on the back end? Is it all in your own facilities? Is it Rackspace, Azure, AWS?
So the main service right now is AWS. That's where we do most of it. For that dedicated, you can run it in any availability zone you want. You just tell us and we'll bring it up in that availability zone, even multiple availability zones. And then we also just announced that you can, if you want, with that dedicated service, you can get it on Google Cloud Platform as well. We can spin it up in Google Cloud Platform. We can actually spin it up in AWS and Google Cloud Platform if you want. Huh. And look forward to other announcements soon.
Awesome. And then I suppose on the payment models for those, it would be done through, you'd have separate contracts with Google, or do you pass those?
No, it's just through us. We're trying to take the hassle out of it for you. So you pay to us, and then we take care of everything under the hoods for you.
Excellent. One neck to choke. All right.
Exactly. We don't want you having to say, well, AWS, it's your fault. No, it's OpenShift's fault. No, it's AWS's. Like, if it is AWS's fault, we'll tell you that, look, their availability zone is down, but you don't have to go to AWS to complain to them. That's on us.
Ah, nice. Okay, so let's say I'm excited and I'm a business owner and I want to move on to this thing, or division head.
Right.
And of course, I've got a legacy system. So
Yes.
let's just make it legacy. So we'll call it J2EE.
Okay. Yes.
And I want to start using OpenShift.
Okay.
So I'd have, aside from all the infrastructure stuff, I would also have to move my code over to a containerization strategy. So would OpenShift, does the tool itself make that easier, or does Red Hat help in some way? How does that work?
Yeah, so that was a later demo I was going to show, but I see that we're about halfway through. Let me show it. I'll show it quickly with Python, and then I'll show you a full JEE app at the very end. Is that okay?
Yeah, sounds great. Thanks.
Okay, so the next demo we're going to do, so that was just, this is if you already have Docker image. The demo I just gave was if you already have Docker images. These could have been Docker images you built from your own code, and you can run it that way. But the other thing I want to show is we have the way to just take source code and build Docker images for you. So what I'm going to show now, I'm going to start here, and I'm going to make, this time I'm going to use the command line. So some people like the command line. And I'm going to use my little script because no one likes watching me put in typos. So I'm going to do a blue-green deployment, and I'm going to do it all from OpenShift with source code. So I'm going to make a new project. Oh, sorry. Let me log into my server. It timed out after 24 hours. So I make a new project, blue-green, and so there we are. And so here's my source code, right? It's extremely complicated Python source code. It's basically one file. And all it does, this is going to show you all of my extremely high-level Python programming. When something comes into the base route here, it calls this function, and it basically returns a string, which is some HTML. So very simple Python code. The point of this is just to show you taking code from GitHub, building it, and then actually I can make a change and build again, or I can actually deploy this multiple times for blue-green. Let's do both. So let's actually start by then going back here and saying OC new app. So I'm going to add, this is a way to add something to my project. And I'm going to use my Python 3.5 builder. And I'll talk about builders a little bit more in a second. So I'm saying I want Python 3.5. And the Git repo I want is this Git repo right here. So it's saying take this builder image and combine it with the source code and build. It's going to make a build config, a deployment config, the services, all the stuff we saw before. And I can talk about those a little bit more, but the main point of this one is a build. So now if I go back to my console, there's a new project called blue-green. And in here, oh, I talked too long. It already did a build. So it took that source code from here. And if we go back here and we look at the build log, you can see it's pulling, this is a normal Python build. This whole part right here is it's cloning this repo. It's doing the pip install of the dependencies, which in this case is just bottle. And then it takes that Docker image that comes out of this build and puts it into our Docker registry. And so if we go back over here, I'll show you what that build process actually looks like. Right, so here's our Git repo that we built. We didn't have any Docker on our machine. We were just doing our normal Python development. And then we had the builder image. And so what the builder image is, it's a Docker image that knows how, it's called source to image, and it knows how to take a source code repository and this Docker image and produce a new Docker image down here that's actually runnable by default. So you combine the Git repo with a builder image, specify it with a build config, which just the platform did automatically. That built the application image, which is then pushed into the Docker registry. The Docker registry is looked at. There's a deployment config looking at it saying, hey, when this image shows up, deploy it. And then it goes ahead and deploys it to the node. Right? So you can see at the end of this log, it says it's pushing blue-green latest. If I go back to the overview, there's the deployment, blue-green. And when you say, what is the image for it? It's blue-green, which is the image that was spit out from the build process. So as soon as that was spit out and put into the Docker registry, this saw a latest image there and then chose to deploy it. And so if we go back, and let's create a route. for that so you can see this awesome application. There it is. So we are from red on blue, green, blah, 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 blah. That's the actual pod name, right? So if we go back here and we look at this pod, that's the pod that it's running in, right? And so now I'm going to show a code change. Let's actually, since this is called blue-green, let's actually call this one blue, and let's make it blue instead. So if I go back here, I'm such an awesome coder that I work right in GitHub, right in master. So I'm going to change this to blue. And then I'm going to change this word to blue. Flexing my impressive Python skills. I don't need continuous integration or continuous delivery. I've made my change. Now, if this Docker image wasn't, if this OpenShift instance wasn't running on my local machine, I could actually configure a GitHub hook to actually kick off that build and deploy right away. In the tutorial that I link to later, this will also be on your local machine. If we were running the public instance where there's an address, we could have actually kicked that off that way. So what I need to go back here. Yeah.
So Steve, builds can be done automatically or on a schedule. Is that right?
Yeah, they can do. I don't know about scheduling. I haven't looked at scheduled builds. What I do know is that you can do GitHub webhooks that say when or whatever Git system you're using. It could be GitLab, but on a webhook can push to the OpenShift instance and say, hey, there's a new tag in this branch or this in master or whatever. There's been a push to the one that you care about. Fire off a new build, and it'll go and pull the source code and do a new build again. And that build could actually kick it into a whole Jenkins instance running on OpenShift. But because this isn't public, I just have to kick off another build here. So here's the build running again. There we go. It's installing the dependencies. And there it's pushed the new Docker image. And I reload this page. Oh, it's cached. Oh, wait, did I commit it? Yeah, I did. Hold on. There we go. I had to clear the cache. That was just shift reload. So there, oh no, that wasn't what it was. Rats. What it was I forgot to show you this moving to making a new pod. It actually did the deployment. I'll show it. We'll do it one more time. Yeah, that's fine. Don't show me that again. Let's do it one more time because I forgot to show it to you. So let's make one other quick change. Steve is coming from, there we go. There's my new change. Commit it. This time, after I push the start build, I'll quickly flip back. Start build, click to the overview. So the build is happening. The build finishes. There's our old one running. So if I actually load the page now, it's still the old content. Now the new one is spun up. The old one is spun down. If I go back here and reload the content, now it says Steve is coming from. So the automatic rollout of the build happens by OpenShift by default. You can actually use that to do a poor man's canary. So a canary is when you usually start rolling something out, look and send it real traffic, and then if it's going wrong, roll back. You could actually, we have the update period here. You could have like 5, 50, whatever, however many replicas, a lot of replicas, and set the update period to be something like 2 hours. And so then what it'll do is it'll scale a certain number up, scale a certain number down, and then wait 2 hours. And if you're monitoring those ones that are there, you can actually watch for bad things happening. But what we can also do is I'll build that same app again now using the web console, or I'll deploy that same code again. So here I'm going to search for Python. There's 3.5. So this is another way of doing that same build, except this time I'm going to call it green. And let's see if we still have the, nope, we don't have the Git URL. It's still in the copy buffer. So let's get it from here. And so now, if I go back to the project, we will be kicking off. There's green. So there's the build happening for green. So this one's still up and running. It's still available at this URL. When this build and deployment is done, there'll be a new one available at this new URL. and it'll be exactly the same as the other because I didn't change the code. So let's actually go in here, edit this file, make this green. And then change this to green. Okay, make that change. And then green is done. You can actually, and now I'll actually just refire the build again, just to get the change we want. In the meantime, while that's happening, I need to fire up Firefox because we'll need that to show off what I want to show.
Cool.
Any questions?
No, none so far. Following along.
Okay, so now that should be done. If I go to the overview, we've now got green, and if I click on this link, there's our new green. So what we have green, this one's coming, this one's still showing Steve is coming from, this one's, so there's two services, and now we want to do a blue-green deployment. And what a blue-green deployment, at least the way I think of them, is you have one service up and running, you bring the entire new version of the service up and running, do all your testing against it, and then switch over between the two. And what I'm going to do is we've got both of our services up and running, responding on different URLs. I'm going to actually make them both respond to the blue-green URL. And that's as easy as going to the application, go to the route. So that was the blue-green URL. And I say edit. And then I can split traffic across multiple services. So this route, there's blue-green. There's my service green. Right? I want to route now to green. I'm going to change this to 100. I'm going to change this to 50. And I'm going to change this to 50. And then I'm going to save. And so now, if we go back to this route page, you can see that 50% of the traffic should be going to our blue-green service, and 50% should be going to green. So here's the blue-green URL again. I reload the page. Still, we have session affinity set on with HA proxy by default. So this is going to keep going to that same pod. But if I go here, sometimes this, and that one comes from green. Same URL, if you can see up here, that's the blue-green URL, but it's actually serving up from the green service from a green pod. And then, if I wanted to, I can actually go, if I wanted to switch it completely over or change the weights, I can do that here. But I can edit again, and I can remove the blue-green service. So I can set this to green. And now all the traffic, if I reload that, should be coming from green, right? Yes. So if I go back to this one, and I do a fresh reload, it doesn't want to work for me. They're both going to green. Oh, it changed this one to, oh, that's why, because it changed this one to blue-green. Blue, so I can remove this service now. There we go. Now if I reload this, you notice it doesn't have the split anymore because it's all going to the service green. And if I reload that page, it's all on green. So in that one, I showed how to do a build. So back to your original question about you migrating an app. As long as your source code, your Java source code uses Maven, which is what most of our builders use right now, you can just start building your source code against either, we have builders for Wildfly and JBoss, but we've had some external people build some for WebSphere Liberty as well, right? So against any of those, you can just give the source code and we'll build you a Docker image that will actually run and do all the stuff you want it to do. And you don't even have to know that Docker is happening under the hoods. Any questions?
No, none so far. Thanks for illustrating this. This is one part that I think we didn't see during the TCO and the EPA challenge. So this is really something. Thank you.
Oh, okay, so now let me show you quickly the one you wanted to see. right? And this is kind of the tour de force. And if we have time, I'll go back and show, we have a partner called Crunchy Data Solutions, and they've been building a lot of work around Postgres, and they've actually enabled master replication right out of the box, doing just 2 commands, and I've got those databases set up and doing streaming replication right away. I'll show that if I have time or if we don't have any questions, but I'll show you the tour de force first. Now, maybe I'll just show it anyway and we can let the video go. I mean, if people need to leave, they can leave. Let me just, is that okay? Can I just show the master replica database streaming replication?
Oh, yes, absolutely.
Okay, so let's do that one next. And I'm gonna do this one from the terminal as well. So we're gonna do a new project called Spatial App. So back at the command line, let's get this back up to the top of the screen. All right, so now we're in Spatial App. I do this as part of my PostGIS work, which is a spatial open source database using Postgres. So let's see, I'm in the right directory, and then I just do OC new app. So what this is doing is, remember how I said there was truth of the world? This is truth about how to spin up a Postgres image. Let me just show you what it looks like. So what this is it's a template, and there's a parameter, which is what I fed in, which is the image tag, so I could specify which crunchy Postgres image I wanted to use. And then it says, okay, this is going to be a service, okay, which we talked about before. What are the ports and do they have names? Yes, this one's named Postgres, and it's port 5432. This is another port, and it's called PC Badger. It's TCP, and it's on port 1000. I haven't talked about selectors. I don't think we have enough time to talk about them now. But here's a pod. We're going to spin up a pod, and inside of this, we actually have 3 different containers. So remember I said we could have more than one container in a pod? Inside this pod, we have PG Badger pod, which uses this Docker image. We have PG Collect pod, which has this Docker image and some parameters on it, usernames and passwords, and a volume mount, so that's some data that it's going to mount. And then we have the Postgres pod, and it's using this Docker image with these ports and these usernames and passwords and all this other stuff. And then these are the volumes, which again is back to that persistent data storage that we want to actually use in this application. So that, when the team that spun up your cluster for you, they made JSON files like this that corresponded to what your starter app does, so that when people do it, it just spins up. They made JSON files which were the truth, and when people told them do the truth, the cluster just made the truth happen. Does that make sense? So the other thing I'm going to do is I'm going to now also do the replica. Is it replica or replicas? Replicas. And there we go. So now, if I go back to my web UI, I go to my projects, there's another one, Spatial App. And I've got 2 sets of pods. There's the master, and there's the replica. And I can scale that to 2, and that's automatically going to start streaming from the master. So one of the fun things I can do is I can actually put data into the master. And I'm going to do this by rsyncing data from my local machine into the pod. So we give you the ability to rsync from your local machine into the running pod. Now remember, if the pod goes down, containers are immutable. So if you write to it and it crashes, when it comes back up, it won't be there. It's just like an Amazon AWS image. But what we only need that data there so that we can load it into the database. So we're going to rsync it from our local machine, which should be in my other tab. I think. Yep, there's a DDL directory. So there's the rsync. We're saying rsync the DDL directory here to the master pod, to the /temp directory inside that pod, in the pod, in the container called PG. Because remember, there was 3 different containers inside that pod, so it needs to know which container to put it in. So there it did. It sent the data in, and now if we go back to the command line, I showed you shelling into the container before using the web console, but here I can do it also from the command line. I just want to show you that. So that's actually the shell inside of the running container. And then because no one likes typos, I'm actually going to load that file, the SQL file, into the database. So there you can see all the insertions. Done. It is done. And then I'm just going to connect to the database. And then I'm going to say select count bar, see, typos, park points. There's 547 rows, right? So we put that, all I've touched here is the master. I'm now going to go back over here into the replica. I can go into either one. Let's go into this one. We'll go into the terminal. We can say PSQL user DB. So I'm into the user DB, select count bar from park points. There's 547, and that's in one of the replicas, right? And so you can see I got streaming replication as a developer without having to do anything to Postgres. And this is one of the, when I first saw this, my jaw dropped, right? Because I've always known as a developer, I should be using a master with replicas in my web application because I want high availability. But then I go and I look at the documentation about how to set that up. And I'm like, oh, that's going to be a week's worth of work. And I'm not sure that I'm actually even going to set it up properly in the end. But here, the experts at Crunchy could actually make the containers that do this. I just have to do a couple commands and I've got it running right away for me. And so now in my application, I can even, because we even have different services, right? There's a master service and a replica service. I can do all my writes only to the master service, and I can do all my reads only from the replica service. So I can actually even have two different services in my code that I'm doing writes and reads to whenever I do them. And so I love how easy and great this makes life for me as a developer and getting advanced functionality that would have been impossible for me to set up. And I probably would have messed up my whole machine trying to get it working and getting the host names right. So I just thought that was a really great demo and give some of the power of the entire platform. And now I'll just do my final one, which is my tour de force. So, and this is what you were asking about before with a JEE app. So I'm going to make a new project. Let's go to this window. So I made a new project called National Parks. And then I'm going to do what our administrators did for you in your hackathon. So here we go. I've got a JSON file that's sitting in GitHub. And I'm going to say, load that up and make that a template in the web UI. So this is going to pull it straight from GitHub, not even from my local machine. And what it does is it makes a template. So when I go into the web UI, and that was National Parks, right? And I say add to project, I can say National Park, there it is right there. Right? That's the template that I specified back with that JSON file. It's now available to any user. They don't, as a normal user, I don't even know that somebody did magic behind the scenes. And this is probably what you guys saw in your hackathon. And it pre-fills in a whole bunch of information, like what's the Git URL? What's the application host name? I'm going to leave it blank because I want the platform to fill it in. But like, what branch do I want to use? This I can actually change if I had made a fork of his branch and make it mine. We're going to make a Mongo database as part of that specification. If you want, we'll auto-generate the usernames and passwords. So we're going to leave it empty. Anything else you wanted to put in, you could put in there. And then we just say create. And so now what's actually happening is a whole bunch of work. So Mongo's already been spun up. That's actually MongoDB 3.2 running. And then if we look, there's a build happening now as well. Right? And so now we can watch a Java build. And for those of you who actually have done Java builds with Maven before, you know that the first pull is basically downloading the entire internet. So here it's downloading now all the dependencies for that application. But this is no different than it would look in a normal Maven build on your machine. Right? So this is, again, back to that scenario where, oh, I've got some code that I want to get it into a container. Well, you can use this right away to start seeing how close you are to getting that container, that code up and running. And the benefit of getting it here now is that you can start getting some of the advantages of the auto scaling and all that other stuff that I showed off before, and ease of use. And there we go, still downloading. Any questions while we're waiting for this build to finish? Oh, there we go. There we go. And now it's pushing the layers. Too fast for questions. So now it's going to actually spin up that image that it created with the build. And then here's our app. So here's national parks with a map. And this is actually using clustering of pins that are getting pulled from a REST API in our Mongo database. So if we zoom in here, you can see the parks, and you can see the name of the park when you click on it. Right? And so you can scale out to the entire world. And this is all running in my OpenShift cluster. And so one of the things that's great for companies, if you're bringing in somebody new, you can have this templated app ready to go. And you just tell them, OK, get your OpenShift username. OK, great. Fork the Git repo. OK, you got your fork. Fill in your Git repo into the template. Go. And so they've already got a whole working version of their code ready and going on in their first hour of getting going. And they can now start making changes and playing around and seeing what happens without affecting anybody else. And then one of the other nice things, remember how I said there's that truth of the world? You can actually also spit the JSON out from the project, and you can then feed that into another project on a completely different cluster. And as long as that other cluster can see the same Docker images, it will deploy the exact same thing. So you can be working on your local machine and then just deploy that to some production server. Or the devs could be doing it on a dev cluster, then they move it to a QE cluster, and then they move it on to a production cluster. Or there's all sorts of different promotion scenarios I didn't even talk about, because one of the things is the QE cluster may not even have the build. They just may be watching the Docker registry for a specific tag with a deployment config. So when the devs are done, they tag their Docker image that comes out with QE ready. And that automatically triggers the deploy into QE, right? And you can also set that to a manual deploy for production when it says prod ready as the tag in the Docker image. When that shows up in the registry, it doesn't do a manual deploy. I mean, it doesn't do an automatic deploy, but it's ready to go into that deployment as soon as the production people click the deploy button. So I hope that I've showed you today how easy it is to get started just running a Docker image that you have, and then all the different ways that you can leverage OpenShift, either in a hackathon or in your everyday work, to be more productive, get going with containers faster, do things that you would never do as a developer before, like that blue-green route or master-slave replicated Postgres. Those are things I never would have attempted as a developer, which are now easily within my reach. So thanks for your time. And if there's any questions, I'll take them now.
Steve, thanks a lot. We really appreciate you doing these demos. That last one was wicked cool. That definitely, I see why you keep.
I like that. I'm a geo person by default, and so I love when there's maps up there. Maps. So
yeah, we're big fans of maps here at TopCoder. No question about it.
All right. So yeah, so I should give this is also OpenStreetMap data. So big fan of OpenStreetMap data too. That's underneath it.
Oh, cool. Pulling it in.
Yeah.
So, Steve, thank you very much. I think we can proceed to wrap it up here.
Okay.
If anyone in our community has questions, they're able to, after we deploy this webinar recording, they can do it by entering them into the TopCoder forums, and we'll make sure they get to you. But also, do you have a contact that you'd like to share for if our members or any of our staff have follow-up questions?
Yep. So for me, well, so here's the take homes. Again, sorry, I forgot this part. The take homes is all the stuff I said, but here's the PDF that tells you how to download a Vagrant and VirtualBox if you want to play with this on your own desktop. This is the link to the slides again. And then the very first slide had all my coordinates. The best ways to probably get in touch with me, email, but that kind of gets swamped. Direct DM on Twitter is pretty good. And I don't play Ingress as much anymore. And the Steve Zero is not my Pokemon handle. And I don't play that much anymore either. So probably Twitter and my email is probably the two best ways to get in touch with me.
All right, awesome. And Nick, maybe we can find a way to post these links outside of the recording. But Steve, once again, thank you for joining us. We really appreciate you taking the time to do it. We'll make sure if any questions come on, we'll channel them over towards you. And is that a cat behind you?
Oh, no, actually, sorry. I should have given her credit also for my talk. That's my dog. She helped me present the whole talk. Good girl. Very good. Yes, I couldn't have done it without her.
It's an all hands effort over here.
Exactly.
All right. Well, thanks again for joining us. We look forward to exploring more opportunities with you. This is really cool stuff.
Great.
And
I look forward to working with you guys too. I love the work that Top Coder does. So
awesome. And we'll see you in
Right.
virtual land.
Okay. Thanks, guys.
Take care.
Bye.
Bye-bye.